Here's the first problem for the mock exam for functions and linear models. So you have a plumber in Australia charging 90 Australian dollars per hour of work plus a fixed cost. His total charge is represented by the cost function C of t equals 60 plus 90t, where t is in hours. So when you write C of t, that's kind of like the y of the function, the output of the function. And the reason why you put t in parentheses is it's to show that c is a function of t, or that on the right side, the variable that's going to be there is t. Sometimes the way you'll see this is f of x, where x is the input variable and f of x is the output variable. In this case, c of t is the output variable, it's the cost. T is the input variable, it's on the right side. Okay? So it says write down the fixed cost. Remember that the fixed cost is kind of like the initial fee for a party, for a bowling alley or something like that. It's what you pay that's not per person, it's not per hour, it's just you pay it the minute the guy shows up. So in that case, what that corresponds to is the 60 here, because that is what is paid even if t is 0, right? If t is 0, c is equal to 60. So the fixed cost is 60. It takes 3.5 hours to complete a job for Paula. Find the total cost. Okay, so in this case, there's a couple ways to do it, and one of the ways is just to substitute it into the function, which would be c of t equals 60 plus 90t. So actually, we're saying that t is equal to 3.5 or 3.5 hours. So basically what we're saying is c of 3.5 is equal to 60 plus 90 times 3.5. So you could just like do that math and figure it out. The other way is you could put the function into the calculator. So I'm going to put 60 plus 90x in the calculator. 60 plus 90x. And then I could look at the table, and that would kind of give me a whole bunch of different possible points. And in this particular case, I want x, or t, equals 3.5. I don't have 3.5 here. But remember that I could go down to 3, and then I could do a plus 0.5. And that would change my step size so that I do have 3.5 there. And in this case, I can see that the y value that corresponds to t equals 3.5 or x equals 3.5 is 375. Okay, and the other way, of course, I could do it is I could actually do 60 plus 90 times 3.5, and that would actually give me 375. Another way you could do it is you could look at the graph. And if you look at the graph, it's kind of hard to see because the thing like goes off the screen immediately, but we could do zoom fit, and then we could actually see the entire line on the screen. And if we do that, then we could use trace 3.5 to find out when the line has an x value of 3.5. So we go trace 3.5, and that'll show me that the y value that corresponds to x equals 3.5 is 375, as we just saw. Okay, so those are like 3 different ways to do it. Let's go to C. Steve receives a bill for 510 Australian dollars. Calculate the time it took for the plumber to complete the job. Okay, so I'm going to show you a couple different ways to do this too. So one of the ways is 510 Australian dollars. Does that correspond to t? Or does it correspond to c of t? So 510 Australian dollars is the cost, so it actually corresponds to c of t. So we could do an algebra problem, and we could say 510 equals 60 plus 90t, and then do algebra to solve for t. We would subtract 60 from both sides, we would divide by 90 later, right? Let me show you how to do it with the calculator. So you could program 60 plus 90x in the calculator and do second table. And then we're going to look for the number 510. Now the question is, where do we look for the number 510? Do we look for the number 510 under y or x? Well, remember, 510 refers to c of t, not t. So it's actually referring to the output. So we should look for 510 in the y column, and we find it here, and we see that the t variable is going to be 5 at that point. So we'll say that the t value is equal to 5 in the case that the y value is equal to 510. Okay? Let's look at the last one. It says to find t when c of t equals 105. Now, if c of t equals 105, does that mean that t is 105? Does that mean the output is 105? Does that mean y is 105? So remember, t corresponds to the input variable x, y, the output variable, corresponds to c of t. Okay, so c of t is equal to 105, so that means we're looking for when the function is equal to 105. Let's see if we have that. Yeah, looks like we have it when x equals 0.5. So when x equals 0.5, or when t is equal to 0.5, we can see that the c of t value, or the output, is equal to 105. Okay, and we could see that because we changed the step size to plus 0.5, we can see a lot more points here. I'm going to show you how to do that on the graph too. Okay, so we have it graphed here, and we want to know when the y value is equal to 105. We can do that by putting another function that is y2 equals 105. What that does is it creates a horizontal line at the height 105. Then I just find the intersection point here. The way I find the intersection point is I do second calc intersect, and then I just hit enter a couple times to say first curve, second curve. Yes, it's the two curves that are there. I put a guess, which it doesn't matter because it's two straight lines. They only intersect at one point. And the intersection is 0.5 comma 105. So the 105 is the function height that I put in there, and the t value that solves the equation is 0.5, so I get the same answer out, right? I could also do that to find t equals 5 solution. Here, I could put a y2 equals 510 function here, so instead of putting 105 here, I could put 510, and that would help me find that the x value is equal to 5 here. Okay, so that's it for this problem, and please look in the other video for the answer to problem 2.